Section 4.4 is very similar to 4.3. You're going to solve quadratic equations by factoring still. What the difference is here is you will start to see a number in front of your x squared. In 4.3, whether or not you noticed it or not, it was always just x squared plus a number plus a number. Well, now you could have a 2x squared or a 5x squared or whatever the case may be. So first step, as always, regardless of what type of quadratic it is, you want to see if you can factor anything out of each term. This is that greatest common factor. It just makes the problem much easier for us to deal with. Here's what something might look like for this section. You can see there is something in front of your x squared, but you want to follow that first step. Can you factor anything out of each term? And you look at all three terms, and well, when they're all even, you certainly can factor a 2 out, and you're left with a 5x squared plus 16x plus 3. And now we say, all right, how can we factor what we have left, this 5x squared plus 16x plus 3? So I won't go through the factoring here just because there's some videos for you to watch on it, but when you have a number in front of your x squared, you're basically going to have two options for how you want to factor. You can guess and check, and I have some videos for that, or you could try something called the FIFO method, factor in, factor out. I do not care how you factor, so watch all of them, figure out which one you like better, and then just continue factoring that way, but make sure that you're getting correct answers when you factor. Whether you're guessing and checking or factoring in, factoring out, doesn't matter to me, just get right answers. You will see special patterns here, again, like we did in the last section. Here we've got two terms separated by subtraction, so this could be a difference of squares pattern. So you look at the first term, did we square anything to get a 16x squared? And we'd say, oh yeah, a 4x times a 4x is 16x squared. Did we square anything to get a 1? Well, that's a 1 times 1, and we have found the difference of those. So this is your difference of squares pattern. So your 4x's will go here, and then remember you have a plus 1 and then a minus 1. So opposite signs on those. Here's just another quick example. Two terms, check to see if it's a difference of squares. We're subtracting, so there's the difference. Did we square anything to get a 36x squared? That's a 6x times a 6x. Did we square anything to get a 9? Well, that's a 3 times 3. Oh, and you know what I forgot to do? What's that first step of factoring? First step of factoring always will be, can you factor anything out of both terms? And in this case, what is it, a 9 actually will come out. And you're left with a 4x squared minus 1. And then, can you factor what's inside? Well, two terms with subtraction, that's a 2x times a 2x, that's a 1 times a 1. So you have 2x plus 1 and 2x minus 1. And we can't forget to bring that 9 down, and that would be the final answer. Now, if we hadn't done this first step of factoring the 9 out in the beginning, let's just take a look at what this problem would look like. How I originally started it. We said it was a 6x times 6x and a 3 times 3. So 6x plus 3 and 6x minus 3. And the thing that we would now have to catch if we forgot to factor the 9 out in the beginning is these two, you can factor something out of each of these. You know, you could factor a 3 out of this first parenthesis, and you would have 2x plus 1. And you'd say, oh, well, I could factor a 3 out of there, too. And you'd be left with a 2x minus 1. And those two 3's out in front would get multiplied, and you would have 9, 2x plus 1, 2x minus 1. So, same thing, but just a little bit less work if you can take that 9 out in the beginning. So again, the reason why we want to factor is because we want to be able to solve these equations, solve for x. So I have some videos for this. Basically, you're going to get this into factored form, and then anywhere that you see an x, you're going to be setting that equal to 0 and solving for x. I wanted to just throw this one up here too. If you notice, when we factor and then solve, we have to be equal to a 0 over on this side, or the other side, whatever side it may be, which means if you're given an equation that looks like this, we want to get everything on one side so that it equals 0 on the other side. And then just a helpful thing to make sure you follow, find that x squared term, and you will always want this term to be positive. So because it's positive over here on the left side of the equal sign, I'm going to leave the x squared term on that side and get everything else over here with it. If you have a negative number in front of your x squared, it just becomes more of a headache with your factoring. So just always have a positive x squared term when you factor and then solve.